Good morning, everyone. You've already taken a seat. If we could just quiet down, we'll get started today. So I'd like to welcome you all to the second day of the 2013 Summer Teacher Institute, Natural Disasters and Social Responses, A Global Perspective. My name is Alex Barna. I am the Outreach Coordinator for the Center for Middle Eastern Studies at the University of Chicago, and I'm part of the planning committee for this year's Institute. The theme of today is engaging crisis, so we'll be, I hope, building upon the theme of yesterday, defining and anticipating disaster, and taking the conversation further through the lectures from our outstanding speakers that we have today, the question and answer sessions, and the discussion sessions that we have worked into our schedule. I'm very excited about our speakers today, and I'm very pleased to introduce our first speaker this morning, Professor Jill Schneiderman from Vassar College. Jill Schneiderman is a professor in the Department of Earth Science and Geography at Vassar College and a faculty member of the interdisciplinary programs in science, technology, and society, as well as women's studies. She applies knowledge of geologic time and the pace of change to considerations of environmental equity and social justice. Dr. Schneiderman received her BS in geology from Yale and her PhD in geology from Harvard. She was a Fulbright Fellow at the Center for Gender and Development Studies at the University of the West Indies, St. Augustine, Trinidad in 2003, and a Contemplative Practice Fellow of the Center for Contemplative Mind and Society in 2010. She is the co-editor of 3 books: The Earth Around Us, Maintaining a Livable Planet, 2003, For the Record, Geologists on Intelligent Design, 2009, and Liberation Science, Putting Science to Work for Social and Environmental Justice, as well as author of numerous scientific papers. Prior to joining the faculty at Vassar, Dr. Schneiderman was a Smithsonian postdoctoral fellow at the National Museum of Natural History and a Congressional Science Fellow in the Office of the Senate Minority Leader in the 104th Congress. Please join me in welcoming Professor Jill Schneiderman.
Thanks for that nice introduction. Okay, great. Well, I am really so happy to be here. And I appreciate being invited. The whole endeavor is one that really speaks to many things that I care about. I'll just tell you at first that my geological research work has moved from the area of considering the formation of mountain belts in hundreds of millions of years ago to studying little sedimentary particles that get transported by river systems into deltas. So my research has been mostly in the Yangtze Delta and the Nile Delta. And part of those research endeavors have been in order to try and understand something about climate change. The theme, a global perspective on natural disasters and social responses, is one that really matters a lot to me. And from learning from Alex Barna, who I thank for that very nice introduction, I guess I understand that you are trying to explore some of the challenges. I'm just getting myself adjusted here. Okay. Some of the challenges that are involved in understanding and responding to natural disasters around the globe, and then to prepare you to help your students understand some of the material that's presented at the Institute. And I think that that's a pretty tall order. And I'm sorry that I wasn't able to be here yesterday when you were beginning to try and define disaster and think about how one might anticipate it. I imagine that you're feeling pretty on alert, perhaps, as a result of that. And it's my task, I think, today, as the first speaker, to kind of kick off your exploration, our exploration of how we human beings will engage crisis on a global level. Now, as an earth scientist, I do tend to think on a global scale, in the sense that my perspective takes in deep periods of time and broad swaths of space. So what I'm going to do this morning is take really a vast temporal approach by thinking aloud about what constitutes a disaster and crisis over the broad swath of geologic time, and also take a very wide spatial view of society by thinking aloud about what geoscientists call the Earth system, and thinking aloud about how we can nudge people to engage in the Earth system, which is such a complex one. So rather than focus narrowly, I'm going to look deeply into time and widely across space. Now, I wonder if any of you, has anybody here read Hector Tovar's recent novel, The Barbarian Nurseries? It's a really interesting work of fiction. It's a tale that's set in contemporary Los Angeles. The protagonist is a kind of a prickly house keeper who ends up setting off with the two children in this household in search of their grandfather, and they end up in a portion of Los Angeles on the 4th of July, and about the moment, Hector Tovar, the author, writes, "The growing holiday din reminded every resident of the existence of their many neighbors and all their irritating habits. With each hour, the noise grew and it graded, serving as further proof, if any were needed, of the central inescapable fact that subtracted from Huntington Park's pleasantness the existence of too many people, too close to one another, and too little space." And this, I think, is a theme that Sue Kiefer and her co-authors sound in one of the papers that I suggested that you might want to read, her paper, Megascale Processes, Natural Disasters, and Human Behavior. That is, too many people, too close to one another, and too little space may perhaps be the central, inescapable fact of the Earth, if not all across the planet right now, but really possibly quite soon. So hence the first phrase of my title, which is think fast, live slow, is what I chose to call this talk, because I'd like to communicate to you a sense of urgency about the situation of our global society. The second part of my title, Live Slow, has to do with my desire to be not really a so-called prophet of doom, but rather a fellow terrestrian, which is a term I get from a Jesuit paleontologist who I admire, who I'll talk a little bit about. I'm taking the long view of time and try to help us think about how we can cultivate sensibilities that could lead to a just future for the Earth and all the beings on it. If you did have a chance to read the paper by Sue Kiefer, you'll see that she and her colleagues end that paper by proposing a Centers for Disease Control for Planet Earth. And as well-intentioned as I think it is, it's really kind of like pretty policy wonkish. And I don't think that it's something that teachers can really actualize with their students. But I do think that teachers are in a really terrific position to help students cultivate the type of sensibilities that we human beings are going to need, that we're going to need to exude in abundance if we're going to be able to avoid the collapse of the complex civilization that we currently live in. So now, since I wasn't present yesterday to listen to and engage in the defining and anticipating disaster portion of this institute, I just want to take a moment to, as you know, my humanities colleagues would say, to trouble the notion of what a natural disaster is. And I may be a little bit going over some of the terrain that you've already covered, but it never hurts to review, I feel. So I appreciate your forbearance if it goes over some of what you already have done. I'm just, you know, being a geologist, it's sort of, let's see, I see. Okay. Being a geologist, it's sort of obvious to start with this image that you're probably familiar with, which is the Pacific Ring of Fire. Geologists also call it the Circum-Pacific Belt. It's just this zone of volcanism and the associated earthquake activity around the Pacific Ocean. About 90% of the world's earthquakes occur there. And some people would call the death and destruction that has occurred throughout history in volcanically and or seismically active zones natural disasters. This is an image of a kind of a newish house near Zion National Park in southern Utah that was built near the base of a steep rocky slope that was capped by a sandstone cliff. And early one morning, in the beginning of this millennium, the owner woke up with a start as this giant boulder, you know, almost 15 feet across, crashed into his living room and bedroom, narrowly missing his head. Now, Kofi Annan, the former Secretary General, has pointed out that the term natural disaster really is a misnomer. In reality, human behavior transforms natural hazards into what should be called unnatural disasters. So for example, this is an image of flooding. I think this one occurred during Hurricane Ike in 2008 near Galveston, Texas, but it, you know, could have been Hurricane Sandy that happened last fall. It could have been many places along the coast where, you know, we place, you know, a structure that is, you know, obviously in harm's way. And in doing these kinds of things, we basically turn, we turn natural hazards into unnatural disasters. I mean, this is hardly a disaster, but I hope you get my point, that we kind of do it to ourselves. One of the themes that Sue Kiefer and her colleagues sound in that paper on megascale processes and disasters is the issue of population growth. The too many people on the planet, the exponential growth that's portrayed here, Kiefer talks about this as something that's happened because we're the only, quote, big, fierce animals remaining whose population is growing. And not only that, if you look at this chart, you see that increasing numbers of people are living to older age. So we've been able to extend our lifetimes and avoid some of the obvious natural selection processes, and thus we've probably overshot the carrying capacity of Earth, at least with respect to our species. And this is might be considered natural behavior, but it's become problematic to our own survival. That is, our collective human behavior is affecting the physical and biological state of the planet on a massive scale. So Kiefer says, we're heading toward a mega-scale disaster, so big that you'd call it a catastrophe. And I would just put it this way, that our exponential population growth and our extended lifetimes constitute really an unnatural hazard that will lead naturally to disasters. Whether we call episodes of destruction and death natural or unnatural disasters, and whether their causes are natural or unnatural, that's not really what I'm going to talk about, but I wanted to try and make a bridge between what you might have done yesterday when I wasn't here and thinking about, what's a disaster and is it natural? And I understand that one of the themes you talked about was vulnerability and how it's exacerbated by, where you stand in society, and in the landscape. What I really want to talk about is geologic time and the pace of change on the planet, and I want to talk about learning to recognize impending disaster and figuring out how to engage with it. Our theme today is engaging crisis, how to engage with impending disaster as educators of young people who have to maintain their ability to hope, I think. So I'm really going to kind of take a step back and look at a big picture, which is something that geologists just do. It's sort of in our bones, I guess, or somehow it gets cultivated over time. Okay, so I hope you'll bear with me. I'm going to kind of range far and wide from religion to geology, many different things, and I'll try and keep my train of thought obvious and connected, and we'll also have time to discuss these ideas, I hope, after I speak, and certainly during lunch, and I'm happy to entertain questions really at any point, so feel free to raise your hands. I read a really interesting op-ed in the New York Times this past December that Rabbi Jonathan Sachs wrote. He's a member of the House of Lords and the chief rabbi of the United Hebrew Congregations of the Commonwealth. And in that, he reflected on the fact that human beings are moral animals, to use his words, that we hand on our genes as individuals, but we survive as members of groups. And groups can exist only when individuals act not solely for their own advantage, but for the sake of the group as a whole. And so I used the word earlier, terrestrian, which, as I said, I picked up from one of my geological heroes, Pierre Teilhard de Chardin, who is a French Jesuit paleontologist. He's incidentally buried in Poughkeepsie, where I live, and that's another story. He used the word terrestrian in saying that he wanted to provide a kind of account of the Earth, not as a unit in any group, but simply as a person of the planet. I have a picture of him here. He has a kindly face. And there he is in the upper left, his early incarnation as a paleontologist. He wanted to express, and these are his words, the confidence, desires, and plenitude, also the disappointments, worries, and a kind of vertigo of a man who considers the destinies and interests of the earth, humanity as a whole. And he did this. He wrote numerous books, including a couple that I've read, The Phenomenon of Man, The Vision of the Past, and another one that I love called Human Energy. While enduring a lifelong condemnation from the church, he lived most of his life in exile in China. So Teilhard is a hero to many other people, and among the people for whom Teilhard is a hero is another person who recently passed away, who some of you may have heard of, Thomas Berry, who was a Catholic priest who was famous for proposing that a deep understanding of the history and functioning of the evolving universe is a necessary guide for us to function effectively as individuals and as a species. And he liked to call himself a geologian, which is another term that I've been toying with myself. Berry, like Teilhard, wrote prolifically, and germane to our subject and our context at the Teachers Institute, he pushed what he called the great work. The great work, by his definition, is to carry out the transition from a period of human devastation of the earth to a period when humans will be present to the planet in a mutually beneficial manner. Berry, who passed in 2009, believed that the university has a central role in the direction and fulfillment of the great work. And though he wrote specifically about university, I think it's fair to say that he meant schools and educational institutions in general. He was also a little bit harsh, though, sometimes on universities, along with governments, corporations, and religions. These are what he considered to be the fundamental establishments that control the human realm. And he implicated them in promulgating, whether consciously or unconsciously, a kind of a radical discontinuity between the human and the non-human. And Barry, I think, hoped that 21st century educators such as yourselves, such as myself, would steer human beings, would steer students away from roles that extend human dominion over the natural world, and would instead prepare our students for being intimately, word to use, intimately present to the natural world, which I think is germane in an institute on disasters. How do we be intimately present to the natural world? So I'm really happy to be here as an educator myself. I teach at a liberal arts college. My parents were New York City school teachers. I'm a parent with children in public schools, and I really believe in the promise and the potential of education, not just for individual improvement, but really for collective survival. And I know the idea of collective survival sounds sort of grand, but or sort of ominously grand, but I really think that that's what we're confronting, and I think we are in a position to have to think about what Barry called the great work. So in order to talk about that as a geologist, I need to talk to you about geologic time and environmental change, which, I don't know, I mean, at first blush, maybe it seems far afield from natural disasters and social responses, but I hope that by the end of my talk, you'll see that these things are all connected, or at least that why I think that these things are all connected. So I do continue to do a little bit of reading and a little bit of talking, reading things that I wrote that try and weave this story together for you. This is an image from a place on the east coast of Barbados, which is the southernmost island in the Caribbean. And I want to just talk a little bit about this in the following way, tell a little kind of narrative about this boulder in Bathsheba, Barbados. From our perches, geologists discern clues hinting at the qualities of systems that operated in bygone eras. In outcrops of rocks, forgotten fossils, and minute mineral fragments, we find evidence of earlier events on Earth. And to us, present time mingles intimately with the past and the future. In contrast to the work of other types of scientists who derive understanding by observing processes occur, we geoscientists cultivate a perspective that requires patience grown mostly from sitting still or walking slowly in the field and watching not much happen. So geologists really experience time. Really, if you study geology, you do see science whole, and you do see the world in both ways, horizontally and vertically back in history. She had some very beautiful, whimsical musings about a field trip to the Southern California desert with her students that vivifies this kind of timeless and time-full geological realm. She wrote, "One need not be a trained geologist to learn something of Earth's story and history. What we could read in the rock structure around us on the desert revealed that this bit of landscape had been eons in the making, had known both quiet and turbulent times. We were not the first to find fossil fragments in the rock beds. Geologists had reported the finding of bone fragments of a primitive horse, of camels, antelopes, even bears and a mastodon, and the shell of a freshwater mollusk, all of which spoke of a climate in the long past far less arid than now, and an open country congenial to grazing mammals, with here and there good water holes and nutritive grasses, where today only the most drought-resistant shrubs can endure. We knew there had been periodic volcanic activity in the region, for among the rock layers there were thin beds of white volcanic ash, and saline deposits were occluded the intervals of little rain and excessive evaporation of the lake waters. The rock layers proved to be a rich record of history, which I know ties back to the presentation you heard yesterday about the pottery and the shards and the layers of soil in Syria. But Smith's writing demonstrates the fluid ease with which some geologists' bodies and minds move through space and time, which I think is, if you continue to bear with me, germane to the subject of disaster. How do geologists' minds move through space and time? Well, I find resonant a phrase from the historian of religion, Mircea Eliade. I describe geologists' ability as the power to return backwards. And it's really important as we think about how we go forward, we need to be able to return backwards. The poet Pablo Neruda wrote in a poem called Keeping Quiet, we let the earth teach us. So, for example, a few years ago, I spent the year on sabbatical in Barbados, which is this tiny coral island in the Atlantic Ocean. And everywhere I looked with this sort of geological gaze, I could see evidence of changed landscapes and past climates. You see it in this boulder here. It's a tiny island that rose roughly 1,200 feet above sea level in the last 1 million years. It may seem bizarre to say, but it's really a geological infant. Though some of the sandstone and the shale form the island's nucleus, the vast majority of the exposed land is what you see here, limestone, broken debris of ancient coral reefs that have been naturally lithified by a kind of calcareous cement that's derived from seawater. The island is actually quite unique in the Caribbean, unlike other islands there. Like, say, for example, the Bahamas, much farther north, which consists largely of wind-blown sand grains that have been cemented together by the action of rainwater, or other Caribbean islands which are so vividly volcanic. Barbados is really comprised of nothing more than the subaerial remnants of coralline communities and submarine fringes of currently living organisms, colonies of organisms, corals that are hard corals that you're familiar with, or soft corals. These tiny animals called polyps that are related to and look kind of like sea anemones. Each coral encloses itself in a stony cup of limestone that it secretes. And as they grow, the polyps divide to form coral colonies. They build up on top of each other, and then they manifest as a reef. And over thousands of years, these coral reefs respond to fluctuations in sea level, as well as changes in water temperature and other environmental conditions. So on Barbados, I could walk up arid slopes that would reveal the fact that the land underfoot was once beneath the sea, and that hillsides shaped like the treads and risers of a coralline staircase. In geological parlance, we'd call them coastal terraces. They marked ancient shorelines, which is kind of like what you see here to some extent. These old coastal features, some distance above the modern coastline, tell of tectonic uplift, they tell of changed climate, they tell of sea level fluctuations that caused the extinction of some reef colonies and the successions of others. And I can't help it but think of these ancient reefs as a kind of paleontological version of what Buddhists called sanghas, communities that lived and died together. So from the tops of these coralline staircases, I could, peer down into these clear aquamarine waters that bathe these living reef communities and anticipate their eventual end, brought on by rising temperature or by non-point source pollution, for example. Now, the thing about these extended time frames that I think are so important in thinking about when we try and anticipate and engage with the prospect of disaster is that because of these extended time frames over which they occur, these kinds of environmental changes, some of them induced by human beings, are really out of sync with the kinds of lives that we humans live in our current day, which is sort of characterized by nanosecond attention spans. Okay. here's an image. There's a great collection of glacial images from long ago and up to the present. Here you see the disappearance of the Muir Glacier between 1941, or the recession of the Muir Glacier between 1941 and 2004, over roughly 60 years. The disappearance of glaciers and sea ice, soil erosion, deforestation, desertification, accumulating greenhouse gases, habitat fragmentation, all the things that we think of. These environmental changes are what environmental writer Rob Nixon from the University of Wisconsin refers to as attritional calamities. Attritional catastrophes with deferred consequences and dispersed repercussions, which is sort of the opposite or the inverse of what you typically think of when you think of a disaster. Nixon's description is not unlike what Rachel Carson described in Silent Spring as the cost of toxic pollution as, her phrase was, death by indirection. Okay, I think what's most important to note is that Nixon has argued, and perhaps if you had a chance to read that paper that I recommended called Slow Violence, Gender, and the Environmentalism of the Poor, which is actually a chapter of a much larger book he published last year, which is really interesting, called Slow Violence and the Environmentalism of the Poor, that these kinds of slow environmental change are a form of violence, and he calls them slow violence. Now, I always think of disasters as being sort of violent events. And so I've engaged a little bit in trying to think about, well, what does violence mean? There's a Norwegian peace scholar named Johan Galtung, and he wrote a foundational paper in 1969, Violence, Peace, and Peace Research, where he sets out different typologies of violence, which I'll talk about momentarily. But Nixon's characterization of acts resulting in environmental change, the kinds of things that we human beings do that result in environmental change, he characterizes them as having lethal repercussions that sprawl across space and time. He characterizes that as slow violence. So traditionally, violence is thought of as direct violence only, right, with important subdivisions in terms of violence versus the threat of violence, or physical versus psychological violence. But the essential point of Galtung's work is to call attention to and deem most basic the distinction between direct violence and indirect violence. In the former, there's a concrete agent, like, for example, an earthquake, causes direct violence. While as in the latter, there's no such actor, right? There's just spreading desertification and famine that ensues. Drought that causes people to have to be deprived of their potential to fulfill more than sort of the basic work of life of procuring water for families and animals, for example. So by not responding to that, we are kind of promoting an indirect sort of violence, which is a violence that's built into the structure of a system, which shows up as unequal life chances among people. So, well, I'll say more about that in a little bit, but Galtung's really interesting. I mean, there are many dimensions of violence, but I think the most salient point vis-a-vis disaster is that the definition of violence is that violence is the cause of the difference between what could have been and what is. So in a society where life expectancy is twice as high in the upper as in the lower classes, violence can be said to occur. Even if one can point to no concrete actors that attack others, like one person killing another person, this description of indirect violence has some obvious corollaries in, for example, children of lower classes who die of diarrhea because their drinking water quality is degraded. Such environmental degradation can then be thought of as indirect violence. When people become environmental refugees, displaced by rising waters or expanded deserts, something that you would have read about in Lester Brown's book, World on the Edge, which I think Ted Steck recommended that you read, we have to get used to acknowledging that this, too, is a kind of unnatural disaster. It's just a slowly unfolding one, and we think of violence as swift in the same way that we think of disasters as being swift. But disasters and violence aren't necessarily swift. They're just much harder to recognize and see because their timescales are not in sync with human timescales. We live in such a world of this instant connectivity and contracted attention spans that it's difficult to draw our attention to the violence, the disastrous consequences of environmental degradation. I think Nixon's concept of slow violence in the form of creeping environmental change is a type of indirect violence that features the juxtaposition of slow change in Earth systems with the sluggish nature of social systems. I mean, the second part of our topic here is social responses. Slow change in Earth systems juxtaposed with the sluggish nature of social systems produces this, slow violence, which could be considered, I think, to be a disaster in the making. So the violence, the disasters of this type are non-instantaneous, and they're unspectacular, and they're undramatic, and they're amorphous, and they imperil unborn generations of not just human beings, but other living species. Nonetheless, I think it should be within the purview of the critical concern of people who worry about impending disaster. So what I want to argue is just that we need to take a long view of the moment and connect it with a long view of change. And that requires all of us to appreciate the depth of geological time and Earth-paced environmental change. So what I'd like to talk about now is geologic time. And I'll speak in a moment about what I have up on the feature, on the slide here. And I don't know how many of you I know you come from many different, experiences as educators, different levels of at which you teach and subjects that you represent, and I've been advised to just not assume that everybody knows about things that I'm going to talk about. And geologic time, I'd venture to say that most geologists would agree that an appreciation for deep geologic time is far and away, more important than any concept that we have to offer the global community. It's at the heart of earth science, and so I want to take some time to talk about it here. I think it's something that you could teach your students that I think will be a lasting contribution to their lives and perhaps to whatever comes next on this planet. Helping other people understand geologic time is the most important endeavor that any earth scientist can undertake, I think. I think that every single human being, sentient being on this planet, human beings, have to understand how simultaneously significant and insignificant human beings are to the planet and all the other beings that live on it. And I think understanding geologic time makes it possible to appreciate that reality. So what I have projected on the screen here is a typical depiction of geologic time. And when geologists depict time, we always put the oldest time at the bottom and moving up to the present day. So starting at the bottom, right, we have the major eras, the ones that you're probably most familiar with: Paleozoic, Mesozoic, and Cenozoic, and then the Precambrian is just sort of a sloppy term for meaning everything before the Paleozoic. And then we have the divisions of these eras into periods. So the Precambrian is divided into the Archean and the Proterozoic, and the Paleozoic divided up into its periods. The Mesozoic, probably most especially famous to everybody because of the Jurassic or the Cretaceous-Tertiary boundary, which is the boundary between these two periods, the Cretaceous and the Tertiary, that separates the Mesozoic and Cenozoic era. The more recent periods of time are divided into epochs. The reason we have this ability to have the finer divisions is that the divisions correspond to major changes in the kinds of organisms that were alive at that time. The major divisions, like the division between the Paleozoic and the Mesozoic and the Cenozoic, correspond to big extinction events, okay? Times when the Earth has lost, by our estimation, more than 75% of its species in a geologically short interval. And this has happened only 5 times in the past 540 million years. So, and I should say, just to, Zoic means life, Paleo means ancient, Meso means middle, and Cenozoic means recent. This boundary between the Paleozoic and the Mesozoic coincides with the coalescence of the major continents into one supercontinent called Pangaea, and the extinction of an estimated 96% of all species in as little as 160,000 years, which may not seem like a little to you, but to a geologist is the blink of an eye. Proposed causes of this major extinction event include global warming, the spread of deep marine oxygen-poor water, ocean acidification, different explanations. Another major extinction between the Mesozoic and the Cenozoic boundary corresponds to an extinction of an estimated 76% of all species, possibly caused by a bolide impact, the famous asteroidal impact that landed at in the Yucatan Peninsula that led to a global cataclysm and rapid cooling, perhaps geologically instantaneously. There's an extinction of an estimated 86% of species in as little as 2 million years that marked the end of the Ordovician period here, this line between the Ordovician and the Silurian, and an onset of glacial and interglacial episodes and repeated incursions and recessions of the sea. It's very interesting to me that recently geologists have proposed that we should acknowledge a new boundary of the geologic period, of the geologic time scale, and that would be a boundary in here, and perhaps you've heard the term the Anthropocene. Geologists have proposed that we acknowledge this boundary of a new geological period and perhaps the end of a geologic era, because biologists are suggesting that a 6th mass extinction may be underway. And we hear a lot about climate change and we hear less about this 6th mass extinction, but known species losses over the past few centuries and millennia indicate that current extinction rates are higher than would be expected from the fossil record. And so that's why geologists have proposed calling this new period the Anthropocene, to acknowledge humanity's role in these coming extinction events. Let me just show you, I've highlighted these boundaries, and I'm going to talk later about this Precambrian-Cambrian boundary, which is maybe quite different than these particular boundaries. And I've put in here, with the Anthropocene period, another era called the Ecozoic, which is a name that I get from Teilhard and from Thomas Berry, and I'll talk more about that as well. So, may I be the first to welcome you to the Anthropocene. There's a great website that you might want to explore at some point. I don't know if I have a live internet connection, but if I do, this will come up. this is a quite a good website that is an endeavor of a number of, oh, you don't have it up here. I only have it on my screen. That's okay. Stockholm University, the IGBP, Global IGBP program, many scientific institutions across the planet. So it's a great website that will give you lots of information about the Anthropocene and how it's playing out all over the globe. Okay, so I know that you're well aware of the litany of all the impacts of humans on the planet. You've probably talked about it in this context, other contexts. But things that are just, like I've been trying to convey, hard to wrap your mind around is the largeness of it all, the billions of tons of topsoil that are lost each year, with really profound consequences to our food supply and the food supply of future generations. Some of the most abundant marine life species becoming commercially extinct because of our unsustainable levels of fishing by factory-like vessels, huge things that use these mega nets, tens of miles long, drifting through 20-foot swaths of ocean water. Extinctions occurring in equatorial rainforests, the outright slaughter of elephants for their ivory tusks, the spread of pathogens, non-native species. Taken together, all these are the makings of another great, this time human-induced mass extinction, which causes us to suggest we're no longer in the Holocene or recent period, but we're in the Anthropocene. What's so remarkable is the fact that we've had such a profound effect on the entire Earth system, the biosphere, the hydrosphere, the geosphere, the atmosphere, in such a short period of time. And I think this comes out very clearly in Sue Kiefer's paper that's linked to on the website. Now, the way geological time is usually depicted in that linear fashion really does us a disservice as we try to take in this, stark truth. These three familiar eras of the Paleozoic, Mesozoic, and Cenozoic, they only account for 13% of all of geologic time. And so there's a more apt description, perhaps maybe some of you have read of it or depiction of it. This is the amount of geologic time, and this works very well with students, I think, and you can, the Journal of Geoscience Education has some great resources on how do you get students of all different ages to engage with and really take into their guts the idea of deep, deep time. This is one of them where you use a 24-hour clock as an analogy. People can, measure out distances or count stairs on staircases, but with the 24-hour clock, the first life evolves at 4 o'clock in the morning. Single-celled algae show up around 2 o'clock in the afternoon. Seaweed around 8:30. Trilobites not until 9 p.m. Land plants just before 10 p.m. Dinosaurs at 11 p.m. Big mammals roughly 20 minutes before midnight. And humans about 1 minute before the 24-hour period ends. So this is a very effective way for showing what a recent, innovation, if you will, human beings are on the planet, and yet in what we do to the place and the disastrous implications that go along with those actions. Here's another one that I invented up myself that I like to use. It's kind of as bodies tend to be proportioned in these parts from what I've read in sevenths this way. So you can sort of have your students use body proportions to illustrate the point. In this scheme, first life is just above the kneecaps. Single-celled algae at the lower abdomen, multicellular life with hard parts such as trilobites. They appear at the chin. And I really like this analogy because I can carry it with me in my body. And so when I think about humans and disasters and global community, I have to take into account kind of the supersized effect of our relatively short stay on Earth on all kinds of living beings as well as on the physical planet itself. So I guess I'd like to assert that another substantial cause of the present devastation is found in a form of consciousness that Thomas Berry wrote about in his book, The Great Work. It's a form of consciousness that establishes a radical discontinuity between human beings and other living beings, one that kind of privileges the rights of human beings over all other beings. And it's a way of thinking that allows other living beings to have value only in as much as they're useful to human beings, and this is what's sort of gotten us into the sort of disastrous situation that we're in. All beings that are other than human become utterly vulnerable to human exploitation, and so regardless of whether or not they too are social beings, we sort of feel free to act, with disregard, and in some instances cruelly. For example, we'll catapult, monkeys into space, or, our Navy will carry out tests over 5 years using explosives and sonar devices in the Earth's major oceans, exercises that, euphemistically are said to negatively affect, which means kill, 33 million marine mammals, among them humpback whales that, if you know the work of acoustic biologist Katie Payne, who Krista Tippett has interviewed numerous times on her show on Being, which is a great resource for teachers, I think. She documents that humpback whales have these ever-changing songs to communicate, and yet, we don't think anything about, running these tests and in order to develop our ability to evolve explosives and sonar devices. But look, as depressing as this is, I'd like to try and take a hopeful turn, right? I mean, we are teachers of young people. We're trying to make things work out here. And Thomas Berry called for the great work, which is, I think, that what we're engaged in. He was expressing this hope for a new era when humans and the planet will interact in a mutually beneficent manner, and he called this era the Ecozoic. There's a lot of talk of the Anthropocene. Geologists have proposed it as a period, as I said. I don't hear much talk of the Ecozoic. I prefer talking about the Ecozoic to the Anthropocene because the Anthropocene could potentially be a very depressing, like Kali Yuga and, I guess, Asian religious traditions. Anyhow, Berry's hope for an Ecozoic, a time when humans and the planet interact in a mutually beneficial manner, he built this hope on Teilhard's assertion that we need to act and in a certain way because our individual destinies are dependent on a universal destiny. That's what Teilhard said. Now, modern neuroscience, which I find fascinating to follow as much as I can, has shown that we have these mirror neurons that lead us to feel pain when we see others suffering, and that we're hardwired for empathy, and we incline towards altruism. Among the patterns of reaction in our brains are ones that focus on potential danger to us as individuals, and another in the front of our brain, the prefrontal cortex, that takes a more considered view of the consequences of our actions for us and for others. So the first pattern, instinctive, immediate, emotive, but the second is more rational and reflective. The fast track helps us survive, but it can also lead us to act in impulsive and destructive ways. The slow track leads us to more considered behavior, but it can be overridden in the heat of the moment. So we have to find ways to live slow, which is kind of the second part of what I'm trying to convey. We need to strengthen and promote this slow track, and by doing so, research suggests that we can reconfigure our neural pathways and we can turn altruism into instinct through our behaviors, which is what I think we need to try and do as we contemplate how are we going to engage disaster in the future. Altruism needs to become our instinctual behavior. I referred earlier to this op-ed piece by Rabbi Sachs, and in that piece he also talks about how religion remains the most powerful community builder the world has known. And he says that religion binds individuals into groups through habits of altruism, creating relationships of trust strong enough to defeat destructive emotions. And as you might expect, from the inspiration I take from the multiple theologians that I've referred to so far, you really won't get any argument from me against the importance of faith for fostering kindness and compassion for all types of communities of living beings. And I think that, part of the problem with the academy has been it's sort of the separation, in a way, between, faith and science, or spirituality and science. As much as I agree with Rabbi Sachs that religion is an important antidote to the individualism that characterizes the late Cenozoic, which maybe we've left, I'm not sure, I think there are other antidotes as well, and I find them in the teachings of, say, for example, there's a rabbi whose work I love named Art Green, who addresses this question. He asks, how will we find the wisdom to change our way of life, slow the maddening pace of contemporary existence, and desist from the violent behaviors that have seemed an inevitable part of our biological legacy? And I find them in the writings of Rabbi Abraham Joshua Heschel, who wrote a great book, little slender volume called The Sabbath, who urged the cultivation of what he called radical amazement. In other words, like the will to wonder. The will to wonder. How do we do that? Well, there's a physicist, he used to be on the faculty at Amherst. This is something that he said. The university is well practiced at educating the mind for critical reasoning, critical writing, and critical speaking, as well as for scientific and quantitative analysis. But is this sufficient? In a world beset with conflicts, internal as well as external, isn't it of equal, if not greater importance, to balance the sharpening of our intellects with the systematic cultivation of our hearts? And I think that as we think about so-called natural disasters, we need to enlarge our view of what constitutes a disaster in order to be able to recognize slowly unfolding ones. And we need to not only lead with our minds, but also with our hearts, so that we have a positive way of engaging crises, whether they're swift or protracted. And not just by responding to them, but by kind of sowing sensibilities in every human being on this planet, such that we'll pay attention, close attention to what's going on around us in the ecosystems, to the living beings that coexist with us, to the land, the water, the air that they depend on, so that not only do we see and understand, but we feel and we act compassionately, and we act in a way that acknowledges this intricate web of connections between all the components of the atmosphere, the hydrosphere, the geosphere, and the biosphere. For example, there's a book that came out this year by a biologist named David Haskell called The Forest Unseen, A Year's Watch in Nature. Haskell writes beautifully, and he set himself an unusual task for 1 year, which was to examine a 1 square meter patch of a biologically diverse forest in Tennessee nearly every day, and simply to record his observations. He visited this little patch in the forest on a daily basis, and it gave him a window into the ecology not just of this specific place, but of the world at large. His project was a sort of a project of patient stillness, and it reveals to us, I think, how underappreciated species of animals and plant life are critical to our own health. And I think that his project helps renew our respect for species that we might otherwise disregard. He explores life at all scales, from microbes to mastodons in his reflections, and he shows us how critical the diversity of life is to our own well-being. And I think that it's the type of project that as educators we can undertake, in our backyards, in our schoolyards with our students. And rather than this just being a social response to an impending disaster, we're reorienting human beings to behavior that is based on compassionate attention. This is an image of the walkway over the Hudson, which is the newest of New York State's parks. It's really a beautiful spot, and I like to take my geology students over this walking across on this walkway over the Hudson River. It affords the opportunity to see the glacially carved U-shaped valley that's now occupied by the Hudson River, and the sedimentary rocks and structures and outcrops on the banks of the river, and erosion processes. And since the landscape is always changing from year to year and season to season, the classes of students that I take there are really likely to make different observations. I like them to walk and just notice things without talking, and then on the way back to point out what it is that they've noticed. And I sort of feel a real kinship with Haskell's approach to just trying to teach in this way, because I feel like for educators, particularly science educators, the tools of scientific investigation, things like microscopes and scientific education in the field, need to be used as, Thomas Berry said this, instruments of intimacy. So as a scientist myself, as a terrestrian, as an educator, I inspire not only to teach the natural world through kind of empirical inquiry, but also to make room for that inquiry to be a kind of a revelatory in the Heschel mode of radical amazement, a kind of a wondrous experience. And I want to help in this way reorient the human community toward a greater awareness of the kind of single integral community of the planet. And I want to help strengthen those neural pathways that will allow us to act charitably to all beings. And I realize that, this isn't sort of like a geologist talking about how do we respond to, the injustice and the devastation of a disaster, in Haiti, or one that might happen in Turkey in the near future. But I think that's it's important, but it's also obvious. I think that this is less obvious, and I think that it's something that we need to learn how to do, because we're talking about, as a geologist, I just see the bigger time frame. What I'm going to do, because I realize I've gone on for quite a while, I'm just going to put up the geologic time scale again, and I'm going to end by coming back to geologic time. And then maybe we can have questions or talk, whatever you'd like. By coming back to the geologic time and the history of life that's represented, the history of life that's made up planetary communities over all of this geologic time, this boundary, say, between the Cenozoic and the Ecozoic, or the Holocene and the Anthropocene, I am going to hope that this boundary will be less like these boundaries, not this boundary like the Paleozoic, Mesozoic, or the Ordovician, Silurian, or the Mesozoic, Cenozoic, which were all mass extinctions. But I'm going to hope that the Cenozoic, Ecozoic boundary and the Holocene, Anthropocene boundary is going to be much more like this boundary here, the boundary between the Precambrian and the Cambrian. Because I don't know how many of you know this, but I think this would be an interesting thing to teach with your students and something to aspire to. Because this boundary was not, if you look at it in detail, there may have been an extinction. There was an extinction. But we mark this boundary, it's taken as the flowering of multicellular life. That is, before the Cambrian period, there were only very simple, soft-bodied organisms. The Cambrian denotes, the reason we put a boundary here is not so much because of an extinction, but because this is when multicellular life with hard parts starts to flower, and there's innovation in all kinds of life. It may have been an extinction too. There's a fauna from Ediacara, Australia, called the Ediacaran fauna that seemed to have been large, soft-bodied fauna that was relatively short-lived in the geological record. Some paleontologists maintain that this Ediacaran fauna that did become extinct while there was this flowering of multicellular hard parts, organisms with multicellular hard parts, that the Ediacaran fauna actually represented kind of an experiment in a different way of living on the planet. The Ediacaran organisms were large and flat, and like pancakes or like tapeworms are probably the thing that's alive today that most resembles them. They had a lot of surface area and not a lot of volume, so they were able to take all their nutrients and things that they needed in through their skin. They didn't need like lots of internal folds like large multicellular organisms do. Larger multicellular organisms that are globular do. what's relevant here is that the Ediacaran approach to living in the world at this time was not particularly successful. Instead, some other way of making a living, of being sort of roughly globular in shape with hard parts, proved to be more successful. And so I'm hoping, and what I'm working towards with my students and what keeps me going, is that there's some possibility that this Cenozoic, Ecozoic era is going to represent a flowering of another way of being for living beings on this planet. And that we end up not being like the Ediacaran fauna, but we get it together to act in a different way. Now, so I'll end now, I promise, with just one thing, because I know that I've ranged over all kinds of subjects, but that's just sort of like the way my mind works, and sometimes it's a little verbose, but I do the best I can. I love this book by David Foster Wallace called This is Water, Some Thoughts Delivered on a Significant Occasion about Living a Compassionate Life. Probably the most dangerous thing about an academic education, at least in my own experience, is that it enables my tendency to over-intellectualize stuff, to get lost in abstract thinking, instead of simply paying attention to what's going on in front of me. So I guess I'm not sure whether I over-intellectualize things, but I guess just think fast, live slow. So thank you. Thank you very much. And if you have... Would you like to ask questions, make comments? I mean, I've got lots of time and plenty to learn.
And I will be circulating with the microphone. If you have a question, please speak into the microphone so we have the audio recorded. Any questions for Professor Schneiderman?
Very interesting, thank you. A word keeps coming to mind, evolution. We need to evolve.
Mm-hmm. Yeah, the thing is about, I think, yes and no. I mean, yes, we need to evolve. We need to change. We don't, in some ways, we can't just evolve, because evolve doesn't necessarily mean make progress. It just means change, and I think we need to get better at what we're doing. So, but yes, we do need to evolve in a positive way, I think. And I think that part of that is we can't just keep focusing on our heads. I think we need to have a much more integrative approach. I've gotten somewhat involved in a new association which would welcome, any and all of you. It's called the Association for Contemplative Mind in Higher Education. And it's an organization that's mostly for community college and university, college educators, but all are welcome. And it's run out of the Amherst College and the Center for Contemplative Mind and Society. But, it taps into the fact that, a lot of the neuroscientific research shows that we can change our minds, and that we do need to foster the ability to act, altruistically and with compassion, and that the way to do that is to slow down and to, there was a piece in the Times not that long ago when Hillary Clinton stopped being the Secretary of State. She talked about how she was just looking forward to taking the year off and having a rest, and I said, oh, yeah, she's taking a sabbatical. And I think that, a sabbatical, I think the fact that we've paid so much attention to our minds in education is reflected in the fact that when, at least at my institution, when people say they're going to take a sabbatical, the question is, oh, what are you going to do? Which is not what a sabbatical is supposed to be about. Sabbatical comes from the word Sabbath. It means to have a rest. There's the biblical injunction to have a Sabbath, every 7 days, every 7 years. That's why at least institutions where we have them, every 7th semester, every 7th year comes from the biblical Sabbath, where you let things lie fallow and you see what grows up. And we've sort of lost that, at least in, the fast-paced world in which we live. And even to the extent, I wouldn't deny that we need to, respond when there are crises, but I think in order to see this bigger picture and to anticipate impending disaster, which is, what's coming down the road, paradoxically enough, we have to be still for a moment and pay attention to it and not just react, but to cultivate a whole new way of being in the world. This is a big order. But we're not going to do it just with our heads. And I think educational institutions We need to provide opportunities for our students not just to know, but to feel, which I feel a little bit awkward saying because it's so sort of stereotypically feminine, you know. So I mean, I love it when, you know, when men say this too, you know, that feeling is an important part of the educational endeavor, that, you know, going with the heart is really important.
As a teacher, I find it difficult sometimes to find a way to balance students' belief in religion and God with science. And I come to a halting spot very often as a teacher when I bring up evolution or show that geologic time frame. I was wondering, like, how do you present that to your students that are very religious? And how do you balance that? I mean, I don't find that a lot in the science community, that scientists talk a lot about balancing that belief in God and religion with science, like Francis Collins does, but I haven't found a lot of support in that. And I'm not especially religious, so it makes it even harder for me to kind of bridge that gap. Would you have any suggestions about how to talk to students about that?
Sure. Thank you for asking that that question, because I think it's really a really important one. Steve Gould has written. He was a paleontologist. And a writer he wrote about the history of science, and he talked about science and religion as being non-overlapping magisteria. And I think he had a book called, I think it was called Rock of Ages, but he wrote essays on the subject. And the idea about science and religion being non-overlapping magisteria, the idea being that there's nothing, you know, there's nothing inherently conflictual about these two domains. I don't think there is, and I think that in terms of teaching students, we have to make it okay for people to believe in something and to have faith in something. I mean, I just think that faith communities. I mean, if you look at the movement for environmental justice in this country, that started out, I don't know, I mean, 1987 with the study of the NAACP and the United Church of Christ they put a study together called Toxic Waste and Race. And all of the awareness, I mean, since Hurricane Katrina, I think everybody knows I don't know if everybody knows. Many people know what it means to say environmental justice, or what the environmental justice movement is about. You know, the idea that, I know you talked about vulnerability yesterday, that different segments of society, and we could talk, I mean, when you talk about the environmental justice movement, it just means sort of the U.S., but it's really, I mean, feminists looking at the disproportionate burdens of environmental degradation on women and children in developing countries, that's environmental justice as well. It's the fact that different groups of people are exposed disproportionately to risk and hazard and to poor quality of living because of where they, you know, are in society. And the people who first understood and who first tried to call attention were religious communities. I mean, the United Church of Christ did that study, and I think that it's just, I think that the Academy has kind of given up, like sort of ceded the whole realm of faith and religion to some other realm. And I just think that that's a mistake, because we're in a position where we have to have faith. And I think to validate a child's desire or a young person's desire, my institution, Vassar, frequently comes out as the top of the most, like the institution where students are most likely to not believe in God, or to, like, it has the most atheists, you know, of any college campus. I don't know. It's silly, but it's almost as if to believe in something or to have faith is, you know, gives you cooties. You know, you're not supposed to say that you believe in anything, and I think that that's a real problem, because people I mean, how can you look at these images? I mean, from 2004 with the tsunami, to Hurricane Katrina in 2005, to the Haitian earthquake in 2010, you know, these images are, you know, they're crushing, you know, and we need to respond, but we need to do more than respond. We need to create a society that is different, a global society that is different, and I don't see how you can do that only with understanding. I think you have to do it with a heart as well as your head. So I think to validate and to say, look, these are not in conflict. Science is about the realm of testing things. Religion is not about testing things. You believe what you want to believe. It's not about testing, you know. Is that? Okay.
I really enjoyed everything that you've said, and I've used many of these things in the experiential courses that I teach in the humanities community college level. Teach a course on simple living, and we go to communes, we go to urban farms, and that type of thing. And I also teach a couple of hiking classes where I take students to the Grand Canyon and Yosemite, and we look at the different geological things. But just to kind of underscore what you said about religion, religion also puts people in the life cycles of the universe. And just to give you an example, I mean, we are part of the animal kingdom, and come fall and winter, we go into a phase of hibernation. But what we do socially is we hype people up in December with the holidays and the shopping and the intensity of things, and yet our body and our metabolism goes down in those during the wintertime. We counteract that with artificially pumping it up. And the other societies that I really like to explore are the Amish. The Amish seem to go along with the cycles of nature, and you know, in their carriages they don't have clocks; they have calendars.
Oh, that's interesting.
And the other thing that I've also noticed within my own religious tradition is that I'm Eastern Orthodox. 180 days of the year we are supposed to observe, though we don't, a very strict vegetarian, almost vegan fast. And that, in a sense, allows nature to kind of resuscitate itself. And I think that's another thing that religions have incorporated, and yet we've, in our modern industrialized societies, have kind of ignored.
Thank you. No, let's hear from others. I've done a lot of talking.
I guess one question that I have is why you started off your talk with the population graph, like, because a lot of what you're saying is about how we choose to live, but I feel like when we talk about the big population trends, there's a tendency, at least in the academic circles I've been in, to kind of say, okay, so the Western way of having only a few children is obviously the best because the biggest problem is like this population explosion, and I think that kind of almost goes against the rest of what you were talking about with like the slow living, the like personal choices that we make that are less about like convincing everyone else to embrace our way of doing things. I don't know. I guess I just like saw that as kind of just different from the rest of what you were saying.
Thank you for your question. So the reason I showed that was because I wanted to I think I used the verb to trouble. I wanted to sort of mix it up a little bit, the idea of what's natural and what's unnatural. So that was the only reason I put that up there, that somehow, you know, we have this population growth, and a lot of the population growth is, I mean, there's reproduction, but there's also the expanded timescales. I mean, the longer human lifetime, which in some way is unnatural, and maybe it was a little too cute, you know, like, because I think in some ways it's a little diversionary. I mean, I think your point about simplicity is, and the person who spoke before is really germane to that issue. Like, you know, in countries where people have many children, it's not necessarily problematic in the sense that they're not having, I mean, I think Sue Kiefer's and her colleagues' paper on that GSA special paper on mega-scale processes, she talks about, you know, one U.S. kid is equivalent to 10 or 20 or 30, I don't know, you know, something huge. And I don't know if any of you have read McKibben's most recent book, Earth. making a life on a tough new planet or something like that with 2 A's. He says it's not the same Earth, it's a different Earth. Let's just get real and recognize that it's a different Earth and we have to live differently on it. And he says, you know, I mean, he doesn't say this about, actually, he wrote a book called Maybe One, about having just one child, but this more recent book, Earth, which, like the first half of it, I think you can sort of kind of skip because it like tells everything that we already know, which sort of I probably spent too much time talking about as well, you know, like the litany of all the depressing reality that we exist with. But he says, you know, what we're going to have to do is we're going to have to sort of, it doesn't say hunker down, but we're going to have to, you know, embrace our communities and live locally and stay connected to the web because, you know, it will feed it help us connect us to people, you know, farther away, and it'll facilitate connections among our communities. But I mean, I could see that in a more, I mean, I think what you're saying is right, that, you know, simplicity, and I think Kiefer, I don't know if, yeah, it's Kiefer's paper that talks about this, that the problem is this sort of increasing complexity that's building towards a kind of a critical point where it's just going to collapse, and the answer to that, or the response, if you will, or the cultivated behavior that's required is a kind of settling down and a simplicity. And so larger numbers of people, you know, connecting with one another. I mean, like, I felt ambivalent about getting in an airplane and coming here. I mean, 5 or 6 years ago, when I started to like question whether it was okay to get on an airplane to go to a conference, I felt like a freak. You know, I mean, how can I be an academic and say I shouldn't go on an airplane to a conference? But I actually think about it now. I mean, just because, not necessarily because I think, you know, my one little being getting on an airplane and going somewhere is, you know, contributing to the catastrophe, but it's sort of antithetical to the philosophy that I'm trying to encourage others to have and that I'm trying to live myself, which is to pay attention to how, you know, what I do as an individual is connected, you know, has ripples through the whole thing.
I'm afraid that we are out of time.